Okay, worksheet 2.6. That's the one that you had 1 through 5. Make sure at some point today that gets turned in. And the worksheet we did last Thursday, that was, what, 1 through 12, we did, it was an E-class activity. That should be stapled to it, or you've already turned it in. Okay, because I know some people have turned it in early. Alright, so that was one we did in class last Thursday. So if you were here for that, we did that. If you were not, you should have received that, and then you could watch that video and kind of fill in some of those results. That was just practice with properties. Okay, today, all we're going to do is some notes. We're just going to do some notes on theorems. No homework today. We'll get homework tomorrow. And then Friday, Monday, we'll do our review of the practice guide, which hopefully the sub will hand you tomorrow. If the sub doesn't do that, I'll hand it to you Friday. So, but the sub hopefully will have it like in their possession. All right. So we're going to kind of fly through this today. It's going to be pretty quick. It's just kind of a review day. For properties, or new properties, I should say. So we've had 3 properties yesterday: 210, 211. Those were the postulates we had. That was like protractor postulate and angle addition. Then we talked about 2.3 yesterday, the theorem, which was, I believe they entitled it. It was called the supplemental theorem or supplement theorem. Okay, we're going to do a quick review of those. We have some new theorems today. Now, as I said yesterday, we've had a lot of postulates and a lot of theorems. You can start adding these to that property sheet that, I think it was property sheet for properties of equality and your field properties. You can add those to the bottom. You cannot staple separate sheets of paper to it. You just have to make it fit. So you can fill in wherever you need to. Okay, does that make sense? Alright, we're going to click through this pretty quick today. I want to make sure that we get through these so we can kind of see how these theorems work. I know there's a lot of numbers here. A lot of these are the same. Like you'll notice like the last 4 or 5 we talk about are basically the same theorem. They just say it in different ways. So it's not really saying anything generally new. But I do want to give you the numbers because they're found in your book, they're found in other textbooks. They all kind of look the same for those last few. Alright, so the goals today. Let's review 210 to 11. Let's do theorem 2.3. So I want to review that real quick. These are just going to be one-click slides. I'm not going to do a big discussion on those. And then our new stuff today is these theorems right here. Okay, questions, comments. Okay, let's jump in. This is the 210 we did yesterday. If you were not here, watch that video yesterday. The PowerPoint from yesterday's on the website. So you should be able to do that. I don't know if the video's there yet. I'll have to look to see if Google actually posted it on for YouTube. All right. What we talked about here is that, this is what the book said. Put any numbers, given any angle, any number, any measure can be put from like 0 to 180 for an angle. That type of thing when it's on the line. This was the words I pulled from a different textbook. They were way more specific. They said when you have a line with A and B on it, you put A as 0, you put B as kind of on the 180 line, then you could draw different rays off of it and they would have different measures. Okay, so that's the idea. And you draw them all on one side, so they do this ray on this way, that type of thing. You can find different angles by using that formula the formula that we talked about yesterday, which was this formula. But when you want to find an angle, a measure of an angle, whatever that angle is, you subtract the 2 rays from each other. Like, so if I was finding the angle, let's say this is D here, and that's C, and I want to find this angle here, you tell me what the measurements of these rays are, and you subtract them. So like this right here is 50 degrees. This right here is 146. And what you do is to find an angle between them, you subtract those 2 numbers. That's what this is saying. And you can put them in any order you want. So 50 minus 146, or 146 minus 50, and then you take the absolute value of it. That's how you find angles between the rays. That was what this postulate was supposed to say. The book did a really terrible job of explaining that. But those are the terms from the book. Okay. All right. That was 210, 211. Let me go to the picture here. Okay, this is where you can add angles together to make a bigger angle. So when they're side by side, they're adjacent to each other, that's what we say. So they're sharing a wall and that vertex. You can add the 2 numbers together and that makes the entire angle. Okay? That's angle addition. Alright, and then 2.3 was supplemental. That kind of went off that last one, that you can put 2 angles side by side. They share a ray and a vertex here. When they're side by side and they make a linear pair, a straight line, these have to add to make 180. Well, it's common sense. Linear pair means 180. And you're adding angles together. These can be any numbers you want. So 30 and 150, or 24 and 146, or whatever that is. Okay? All right. Questions, comments on any of that? All right, let's move on. 2.4 data. This is the new one. 2.4. It's kind of like the last theorem that we just talked about, 2.3, which is called supplemental theorem. This was 2.3, right? Supplemental theorem when you add to make 180. Well, 2.4 is basically just the opposite of that. It's the complement. So when the uncommon sides of 2 adjacent angles form a right angle, so this is talking about when they share a wall, right? The uncommon walls form the right angle, then the angles are complementary with each other. So here's the idea. So 2 angles add to make 90, and this is the picture. So that they're sharing a ray and a vertex. The uncommon walls and walls that they're not sharing form a right angle. So when you add these 2 together, you make 90 degrees. You make it complementary, right? Complementary means you add 2 to make 90. Now, in other words for right angles, what do we remember from chapter 1? What are different words for right angles? One of them starts with the letter P. Perpendicular. Okay, things form perpendicular lines. What are some of the other words? There's one that starts with an O. Orthogonal. Orthogonal, we talked about that in chapter 1. And then the other word was flush. That's the word that you seem like drafting. So that's 2-4. The name of this one is called the complement theorem. You add angles, make an angle. Pretty straightforward. Now we've done that before with angle addition, but this is actually a formal theorem. Okay, questions on this one. And again, those two angles can be they can be equal, they can be different numbers, doesn't matter as long as they make 90. All right, let's move on. 2-5. Anyone still need that? Sorry, I'm going really fast. I just want to make sure we get through these. All right, 2-5. This one is a lot like, I'll get rid of that. This one's a lot like Theorem 2-2. If you go back to Theorem 2-2, that was the one where they gave you the properties of segment congruence, where certain angle or certain segments are equal to each other. So that was like reflexive property, and symmetric, and transitive. Well, now what they're doing on 2-5 is they're applying those same reflexive, symmetric, and transitive, but they apply them to angles now. So like a reflexive property for angles, that you can set an angle equal to itself. Why we'd ever do that in a problem? Maybe you need to introduce an angle that something is sharing. So like, oh, I'm going to use this angle that we haven't talked about yet. So we'll introduce it using reflexive. That was an example I did yesterday. And then these other two are the symmetric and transitive properties. So it was kind of the same thing, like the two angles, you set these equal to each other, 1 and 2, and then you can switch the equation around. That's symmetric. And transitive, when you have this big daisy chain of events where all these angles are equal to each other, then the first and last are equal. Okay, questions with Theorem 2.5. It's a lot like 2-2, and it's a lot like the properties on your property sheet. The reflexive, transitive, and symmetric. And again, exact same wording, they're just applying it to angles. So what they call this, they call these the properties of angle congruence. Okay, now on this particular problem, I gave you a couple of pictures here, kind of showing you kind of how this transitive property works. So if I give you angle 1 and 2 are equal, and we know that 2 and 3 are equal, then you can automatically assume that these two are equal, 1 and 3. Because since they're shared like a daisy chain together, the transitive property says that you can set these equal to each other. That's the idea. That one, you can have different angles across the picture. I just want you to make sure that you can make connections between them. Okay, typically when they show angles that are equal, they'll do something like this. They'll put little hash marks in there, little like arcs, to show that those three angles are the same angle, whatever the measurement is. Again, if you were to measure it, then you're using the protractor postulate. This is what postulate 210. Can you measure them? All right, 2-6. Angles that are supplementary to the same angle, or equal angles. So angles that are supplementary to the same angle have to be congruent to each other. Okay, so here's the idea. So we know that 1 and 2 somehow add to make 180. So that means supplementary, right? But then we also know that 2 and 3 add to make 180. Right? These two angles. This is the same number 2. So we have, 1 and 2 add to make 180, 2 and 3 add to make 180. So what can you tell me about angles 1 and 3 from those equations? Can you tell me about angles 1 and 3? Think about that. What can you tell me about angles 1 and 3 from those two equations? It's a logical conclusion to make. Well, they both make 180 with the angle number 2, agree that they're both adding with the same angle number 2 to make 180. But more importantly, 1 and 3, the angles 1 and 3, have to be the same angle. That's what this is saying. Okay, that angles 1 and 3 have to be equal. The reason why, whatever this number is, it's the same number printed here. So let's say this is 30. This is 30, right? So what would that force angle 1 to be? If you have to add with the 30 to make 180. This had to be 150. That's the same here. It has to be the same angle. It has to be 150. Because you're adding it to the same angle as number 2. So what they say, angles that are supplementary to congruent angles are also congruent. So this is supplementary with this angle. This one's also supplementary with the same angle. So they have to be equal to each other. That's what this is saying. Okay, now I kind of paraphrase from the book. They have like a short acronym how they say this. But again, this is the picture. So 1 and 2 add to make 180, 2 and 3 add to make 180. So these two have to be equal to each other, even though they're crossing each other. Okay, it's called the Congruent Supplements Theorem. It's the words that they use in the book. So supplements to the same angle have to be equal to each other. Now, what do you think 2 7 is going to be? This talk about supplements. What do you think 2 7 is? Complements. So angles that are complementary to the same angle or congruent to the same angle are congruent. So here's the example. So 4 and 5 add to make 100, or sorry, add to make 90. 5 and 6 add to make 90. So what can you tell me about 6 and number 4? Can you tell me about angles 6 and 4? They're the same. That's the idea. It's the same exact principle that you're adding. You know, these two add to make 90, and 4 and 5 make 90 when you put them together. So that means 4 and 6 have to be the same angle. Because 5 never changed. It was the same thing shared between both equations. And again, it's called the Congruent Complements Theorem. Yeah, these are just really nice things to like understand. Like when you have pictures and you have certain things that are working out where certain angles are adding up to the number. Probably what's happening is certain angles are probably equal to each other in that picture. Or at least you can find them. All right, let's go to the next one here. 2-8. Anyone? By the way, does anyone still need that? Okay. And again, you should be. Hopefully, you're putting these in your notes. We can transfer them to that property sheet if you need them. This is a kind of a rare case you'd ever need this. Most of the time, you just need to know what the word complementary means. Okay, 2-8. When two angles are formed by the intersection of lines and they are vertical to each other, then they're equal. So here's the idea. So vertical angles are congruent, right? So angles 1 and 3 are equal, 2 and 4 are equal from this picture. So what do we call vertical angles? What was the little like word that I kept using all the time in chapter 1? Not adjacent. They're across from each other, but what was the little word I used? It started with an F. Yeah, they funnel towards each other. So this theorem is actually the actual vertical angle theorem. So this, like before we talked about vertical angles had to be equal to each other. But we never really discussed why. I just said, you know, straight across, those angles are equal. 1 and 3 are equal, 2 and 4. And what I mean by straight across, it can't be a situation like this, where you have this angle and this angle, because they're making like this weird L pattern. That's not a vertical. Vertical is going across this way, straight across. Even when there's multiple angles, you have to look where straight across is. How I view it is this is how I see it in my head. The straight lines make the vertical angles. That's what they're trying to explain. Now, why? Why do these have to work out to be the same angle? Why does 1 and 3 have to equal? It's because of Theorem 2.6. If you look back at 2.6, it said supplements of congruent angles are equal. Well, what do you get when you add 1 and 2 together? What do you get? 180, right? That's a linear pair. And then 2 and 3 also add up to be 180, going this way. That's a straight line. So since they're supplements with the same angle, this is the angle that they're both sharing, that means it forces these two to be the same because of Theorem 2.6. They're supplements of the same angle, so they have to be equal to each other. Because obviously they add to make 180, you can subtract angle 2 and they both have to be equal to each other. Moving on. All right, so that was vertical angle theorem. We've used that one actually quite a bit, but we never had like a formal number to it, which is a lot of these things we've been talking about. Okay, now, if you notice, the next couple theorems, I made this little like overview slide because the next couple theorems don't have names. It's not like, you know, supplement theorem or congruent supplements theorem. The next few theorems are just called right angle theorems. They're all basically the same. That's what you need to wrap your head around. So the next, couple of theorems we're going to go through, they're just doing little stipulations on the same picture. So they're talking about right angles. What's a right angle working? 90 degrees. So that's all we're talking about. So these can get a little confusing, like which one's which. That's why it's nice to like see the picture, see kind of what they're discussing. So a lot of these are just using 90 degree angles. That's the idea. Okay, we'll start with the basic stuff first, and then we'll work our way through like very, very specific things. Okay, so we'll start with 2-9. Again, there's no names. We just call these the right angle theorems. Okay, so 2-9. Perpendicular lines. So we talk about this word perpendicular means that they're 90 degrees, right? Intersect to form 4 right angles. So example, this is the symbol for perpendicular. I wanted you to see that. It's a little upside down T. So when these two lines, or rays, I should say, are perpendicular to each other, then all of these angles are right angles. So here you go. So we have perpendicular. Now you see why all 4 of those angles have to be 90s. They have to be. That's what perpendicular means. It's defined to be a 90-degree angle, and then you can do vertical, and you can do complements, or supplements, I should say, to figure out the others. Okay, so perpendicular lines form 4 right angles. So 1, 2, 3, 4 are all 90 degrees. Moving on to 210, which is the same picture, by the way. 210, all right angles are equal to each other. Duh, because what's the number? What are they all equal? 90 degrees. So the word congruent means they're all the same measure. Well, they're all 90. Duh. So the example, 1, 2, 3, and 4 are right angles. And they're all equal to each other. Well, when you look at the same picture, if they're all 90s, then yeah, by definition, they're all congruent to each other. So that's like common sense. The same picture. 211, same picture again. When you have perpendicular lines, they're forming congruent adjacent angles. Well, that means the angles that are next to each other are equal to each other. Well, duh. So if I show you the same picture again, right, where you have the perpendicular lines, then certain pairs are equal to each other because what are they all equal? What are all these angles? Yeah, they're all 90s. So the pairs that are side by side are all the same angles. So like 1 and 2 match, so they're equal. 2 and 4 match, 3 and 4 match, and 1 and 3 match. So 2, 9, 2, 10, 2, 11, they're just talking about this shape. You make a T intersection. This is the symbol they use for perpendicular, when things meet at 90. Okay, now the next two are very, very specific. They're going to kind of branch away from this picture, and they're going to show you something with perpendiculars, something that's a little more specific. Okay, so 212. If two angles are equal to each other and they're supplementary, so they're two angles are equal and they're supplementary to each other. So what does that mean to be supplementary? They have to add to make 180, right? So if they're going to be equal angles and they're adding to make 180 together, that forces them to each be a right angle. Common sense. They add to make 180, and they have to be the same angle. They have to be 90. 90 equals 90. So that's the idea. 5 and 6 are equal. They're supplements, so they have to be right angles. So here's the picture. They're not connected, but they're equal angles, and somehow when I put them together, they make 180. That means they both have to be 90s by common sense. Okay, questions on that one? I know I'm listening through these, because I want to make sure you get some time. All right, and the last one, this is the absolute last one today. Two congruent angles that form a linear pair. So when you have two angles that are equal and they form a linear pair, they have to be right angles. It's almost the exact same theorem as 212, but now they're talking about this idea of linear pair instead of supplementary. Supplementary means you add and make 180. Linear pair means when you put them together on a picture, side by side, they make a straight line. So if they're forming a linear pair, then they have to be right angles. Like this. So they're equal angles and they're forming a straight line. Now they have to be right angles. The difference between this one and 212, which some people always get confused on, supplementary means you're adding angles together to make 180. They don't even have to be touching. You're adding the numbers. Like, oh, this picture's over here, it's 30. This angle over here is 150. When I add them, it makes 180. Those are supplements to each other, even though they're not connected. This, when they say linear pair, they have to be making the shape. They have to be adjacent to each other. Because if you look back at 212, you can see my angles weren't even touching. They weren't even connected. Okay. Questions on any of the theorems today? They're not like overly difficult. It's just like putting a name and a number to something we've previously discussed. Some of these, they look so close together. All right, so the goal today, obviously you should get your worksheet 2.6 done if you have not turned that in yet. That was the one with proofs. Tomorrow, I'm gone. You will have a book assignment tomorrow, so you need your textbook. Okay. The sub will be in here. They'll kind of give you the idea of what you need to do. They'll turn you loose on what your homework is. They'll put it on the board, hopefully, and you can write it from there. I'll have it on the website tonight. So that way, if like the sub doesn't know what the homework assignment is, it'll be on my website, so you can always check, and you can see that particular unit. Hopefully, they hand you the practice test tomorrow. It should be on the desk here. So I'll hand it to you, and you can study that, and we'll talk about that Friday and Monday. Okay, but tomorrow, you're just basically doing some algebra proofs and a couple geometry proofs. So this is kind of the stuff we've talked about in class. I know a couple of the geometry proofs, since those are like the tougher ones, we haven't done those too much. A couple of them I've shown you in class, so you get a couple freebies, so if you've actually taken notes, it's a reward for you. And a couple of them, like they already have the proof done, you just have to fill in the property names. So it's just some of the basic stuff. Okay, questions, comments? Okay, the rest of the time is yours. You can kind of work on whatever you need to. I want to make sure that you have some time to work on this worksheet too, if you haven't finished.
video.